Selamat Sejahtera Doctor. My name is Chong and I will be explaining about the introduction. Cancer is a major cause of death worldwide, with over 1 million new cases of stomach cancer diagnosed in 2020. China has the second highest incidence of gastric cancer and the third highest mortality rate. At early detection rates are over 90%, but advanced stages can be 10 to 20%. Multiphoton microscopic (MPM) imaging has become a potent medical imaging method for recognizing structural traits of tissue at cellular and subcellular level. By comparing the traditional pathology, MPM imaging has advantages such as three-dimensional imaging, label-free imaging contrast mechanism, and significant penetration depth. And from this image shows the MPM imaging. Moving on for the application of MPM in study of gastric tumors, the majority of the most recent research on gastric cancer use a combination of SHG from collagen and 2-photon excited autofluorescence of autologous intrinsic fluorophores to provide precise real-time data on tissue structure and cellular structural shape. There are 5 applications of MPM. For the first is the normal gastric tissue using MPM imaging. For the second is MPM precancerous lesion imaging. For the third application is MPM imaging for both advanced and early cancer. For the fourth is using MPM imaging for surgical procedure. And for the fifth is MPM imaging of gastric tissue in multi-mode. For the first application, which is the normal gastric tissue using MPM imaging. For early detection of gastric cancer, it's good that if we detect them by the contrast of color in their stomach. As you can see in the first column is the most small cancer to the point it can't be called cancer. That's why we call gastric. And we have the 3 rows over here in the pitch to show that the different modes combine with MPM. By comparing this, it will show the different contrasts and see how they show the output so the doctors can see clearly where the cancer is located. As basically, all of these, the first column, are about the same level as the gastric, but different contrast because it uses different modes.
Next, I want to present about how we visualize the techniques in the biological cell and molecules. You may have heard about the fluorescent microscopy, where shining the light and its goal. This is because the light lets the electron in the molecules to an excited state and this fall back down and give off the light. But there are other way we can do is called the multiphoton fluorescent microscopy. Instead other just using the one electron, we can using the 2 electron proton in the same time. So it's just like hitting a target 2 arrows at once. There has the 2 proton has to reach the molecule very quickly in the outer second. So now we need a lot of line. So why we need has a special laser? They can emit the line really faster like the 18 million times per second. So when we come to finding the thermal in the stomach and intensity, doctor usually using the method called the endoscopy biopsy. So it's not perfect because it can cause the bending, poking holes, and the sample sometimes is too small and it takes a long time to process. Now we have the technology called the multiphoton microscopy, so they can take the picture inside with no actual cutting anything. It has a spatial line. They can bunch us of the tissue in the way and show us on going on inside and no need the label. So the multiphoton microscopy can see the thing really thickly like the small part in our cell, and this can see the lead into the tissue. So there are many scientists using the multiphoton microscopy for the tumors, and they're also using it to study the band and the embryo.
Hi, I'm FIRDAUS and I'll be continuing for the NPM precancerous lesion imaging. Now, it has been used to image precancerous lesions related to stomach cancer, specifically looking for goblet cells, the presence of which it is a reliable sign of IM. It employed 1-photon focal fluorescence endoscopy (OPFE) and TPFE to perform 3-dimensional imaging of goblet cells using the mouse intestines as the IM model. The outcomes demonstrated that in 3D images, both OPFE and TPFE could penetrate to a specific depth, at which point the sliced images of TPFE at various depths display greater contrast and resolution. The prognosis and available treatment options for stomach cancer are determined by the degree of invasion of the tumor, which also defines the tumor stage. Various research groups have endeavored that conduct NPM imaging on tumors at varying phases to furnish a foundation for clinical therapy preference and prognostic assessment, using two-photon excited fluorescent TPEF and second harmonic generation SHG imaging, using NPM imaging for surgical procedures. Now, the treatment for stomach cancer now mostly consists of radical surgery, with various resection techniques established according to the tumor stage. As alternative to surgery for EGC, endoscopic submucosal dissection or ESD and endoscopic mucosal resection are advised. Chemotherapy and active adjuvant and neoadjuvant radiation offer substantial improvements in terms of survival for advanced tumors that have metastasized locally or far. Consequently, for individualized treatment or prognosis, a precise pre-treatment assessment is necessary. The accuracy of NPM in differentiating between tissues with positive or negative margin based on cytological and morphological differences was proven by an NPM imaging research conducted on ESD surgical specimen.
Next, NPM imaging of gastric tissue in multiple modes. NPM uses an ultrafast laser as its driving source in order to produce extremely brief optical pulse. This severe mode-load laser has emerged as the primary workhorse for NPM driving. This explains why these two imaging modalities have been used in all current NPM investigation of stomach issue. Adding more modalities including THPEF and THT can yield more data and make it easier to diagnose stomach tumors accurately. Typically, an ultrafast laser source that produces photomossection second pulse with a center wavelength greater than 1000 Nm is required for the implementation of THT and THPEF imaging. Advantages of NPM multiphoton microscopy allows for deep tissue imaging compared to traditional microscopy technique. This is particularly beneficial in gastric cancer research where the target tissue is often located deep within the organ. Second, NPM is a non-invasive imaging technique, reducing the need to invasive procedure and minimizing potential damage to the tissue being studied. This is crucial for studying live specimen or obtaining longitudinal data. Third, NPM provides high spatial resolution, allowing researchers to visualize cellular and subcellular structures in details. This is essential for understanding the morphological changes associated with gastric cancer progression. 8 advantages of NPM. Firstly, multiphoton microscopy typically has a limited field of view compared to other image techniques. This can make it challenging to study larger areas of tissue, requiring multiple scans or compromising on the overall context. While NPM provides excellent penetration tips for two-photon fluorescence, the penetration tips for second harmonic generation SHG, commonly used for oncology imaging, may be limited in certain tissue, potentially impacting the study of the extracellular matrix. Third, high-intensity laser light used in multiphoton microscopy can induce photo-damage to biological specimen and lead to photo-bleaching of fluorophore. Care must be taken to optimize imaging parameters to minimize this effect, especially for longitudinal studies.
The discussion, NPM is capable in ultra-less ultrafluorescence excitation and harmonic signal. It also can display tissue structure and features of the gastrointestinal tract at cellular and subcellular level. For the clinical important, NPM can accurately distinguish normal gastric tissue, precancerous lesion, and tumor tissue. In terms of visibility, researchers say advancement in speed, penetration depth, resolution, modality, and field of view of NPM. NPM is said to be still in the early stage compared to other major imaging technologies. There will be need for more clinical study to validate tumor validation solely based on NPM imaging. Development and innovation. Urgent challenge is developing a multiphoton endoscope for in vivo application. So, introduction of NPM for optical biopsy aims to minimize disruption in the diagnostic procedure. The goal is to facilitate clinical interpretation by pathologists using color map analog to H&E pathology. For conclusion, NPM imaging combined with a digital staining approach and machine learning algorithm can generate visual transformation H&E images. NPM also offers non-destructive imaging with a larger presentation depth, high resolution, and inherent optical sectioning ability. It also can eliminate the need for complicated steps in traditional histopathological examination. NPM also avoids drawbacks associated with biopsy, such as sampling error, cost, measure risk, and delay in obtaining results. Anticipation that maybe more clinical results will emerge in the coming years as NPM is applied to the study of gastric cancer.